Hi! Today we're going to learn about the limit comparison test. Let's say we have a problem like this. Does the sequence, or the series, from n equals 1 to infinity of n cubed plus 3n squared plus 5 all over 2 times n to the 5th power plus 7 converge or diverge? So here you can see that we have sort of like a rational function here. So as n goes to infinity, this rational function, only the leading terms in the numerator and the denominator matter. So we can cancel out this 7 here, and we can cancel out this 5 here, and this 3n squared, because those terms are not the leading terms in the numerator, and that term is not the leading term in the denominator. So we get n cubed over 2n to the 5th power. So if we take the limit as n approaches infinity, now that we just have what this is as it goes to infinity, so the limit as n goes to infinity, this will come out to be 0. Because we know that the denominator has a greater exponent. Or you can use L'Hopital's rule. So we know that this satisfies one of the conditions for being a convergent series. So because this is equal to 0, it doesn't mean that the series is convergent, it just means that you can move on to the next test. So let's move on to the limit comparison test. So as this goes to infinity, we can see that this can be reduced to 1 over 2 times n squared. Now 1 over 2 times n squared, as we approach infinity, will become similar to 1 over n squared. So we can use the limit comparison test and compare this function and this function we know is what this becomes as it approaches infinity, and compare that to this function here. So the limit comparison test says that if both of these, now here become sequences, if both of these sequences are positive and start from 1 and go to infinity, so here they're starting from 1 and going to infinity, so we have the limit as n approaches infinity of this first one that we want to compare, which is n cubed over 2n to the 5th power, over the other function that we're comparing it to, and we're saying that it's similar to 1 over n squared, so we're going to compare it to that. 1 over n squared. So this would be equal to the limit as n approaches infinity of n cubed over 2n to the 5th power times, because this is how we divide fractions, n squared over 1, which is equal to, so these exponents will cancel out because n cubed times n squared is n to the 5th power, canceling out the n's and leaving us with 1/2. So the limit comparison test says that if this comes out to be, so we divide the function that we have by whatever we're comparing it to, so if this limit comes out to be a positive finite value, then that means that both of these are either convergent or divergent. So we compare this to 1 over n squared, and we know that 1 over n squared is convergent. So that means that this also has to be convergent. So the answer to this problem is convergent. So that's one thing to keep in mind, that when we figure out what values we want to divide, or what other function we want to divide by, we have to make sure that this is a function we know. Is it divergent or convergent of the series? So we have to know whether this series is convergent or divergent. Today we learned about the limit comparison test. Thank you for watching this video.